Hi there, welcome back to the channel. Welcome to this next video in the restoration series for the Nordmende Super 250-9. When I left off last, I was having a serious problem with the power supply with the transformer. I wasn't sure whether it was the primary, the secondary. I wasn't sure exactly what was going on. Now, normally, I say normally, you can't say normally, but usually the transformers don't blow. Okay, they do, but it's not the first thing you look at. When something has worked and it suddenly stops working or it starts showing some faults like that, usually it's something else. Usually it's actually something quite simple. Well, sometimes it's not, and this is one of those times. And so I had to bite the bullet and finally accept that my power transformer was a goner. I've said before that if your transformers are dead, your project's dead. I'm just going to show you that I was wrong. And I've been wrong before. I've replaced transformers before, so I'm going to stop saying that altogether. Power transformers or output transformers are not the end of a project, provided you're a hoarder like I am, and you have old chassis lying around that really are good for nothing except maybe some parts now and then. And fortunately, my hoarding paid off this time, as you'll see if you stick around and watch the video. Also, this is for one of my viewers. He's actually a patron. He's having exactly the same problem that I was having here. The dim bulb was suddenly glowing like crazy. This is what I presume you're going to have to do. All right? But I hope that I explained it well enough for you to be able to do it. Enjoy. This is a disassembled power transformer. And this is the mess that getting it all out makes. Yeah. It gets rather messy, as you can see. Everything thrown around, trying to get that thing out, testing it, and now I've got some reporting to do. I found the problem. But first of all, let me show you where I removed it from. There are 4 screws that go through here. One there, one there, one there, and one there. And of course that black, or rather that brown plate with the contacts and the selector and the fuse fit in the back here. That transformer then slides down, and that's why we've got it out. This is a fairly standard power transformer for these radios. So nothing too surprising over here. We've got 2 secondaries. We've got the heater supply over here. You can tell it's pretty thick wires because they carry a lot of current. We've got the low current but high voltage secondary over here. And then all these colored wires are primary taps for the primary of the transformer, depending on what voltage you're going to use. This red one over here is the one that goes through the fuse, and that's the, let's call it the 0, and then you go up. You know, that's 110, 115, 125, something like that. The top one here, that one there's 240, that one there's 220, and this one over here was actually loose. It had broken off that clip over there, and I thought at first that that was causing a short. But it so happens that it is not the problem. The problem is actually in the primary windings. Now, there isn't a direct short because I can measure resistance between all these, and in fact they go up. I'll show you. If we take the one side of the multimeter to the start of the primary, and we go to the lowest voltage, we get 14 ohms, 16 ohms. That one there that's loose, what was that, about 19 ohms? That's the 220 supply, 31 ohms, and that is the 240 supply, 41 ohms. Well, that should indicate a good transformer, but unfortunately, it's not. The minute I supply power to this, and what I've done is I've connected the supply itself, the mains, I've connected it to there, which is the start of the primary, and to the 240 volts. This thing just goes completely haywire. The dim bulb glows like crazy. It seems to have got worse. The initial loss, or rather short, wasn't as bad as it is now. So something is happening inside here, and it has made this power transformer absolutely useless. Now, fortunately, they do give us a color code over here. And if I can just read it, this is brown and brown. That's the 6.3 volts 2.84 amps, if I'm reading correctly. Then you've got, what is that? That's yellow. That's 230 volts. 230 volts plus minus 5% at 140 milliamps. So that's what the secondary is supposed to supply. And we've got, let's see, that's a secondary. So that is, that's gold and gold, which is actually correct. These are sort of gold, or is it yellow? I'm not sure. And then it gives us the top ones, which are 0 volts is red, as I mentioned. 110 volts is, I can't read that. 125, 150, that's white. And it goes all the way here to 240 volts. So the fuse is fine, the selector's fine. It's the primary windings that are kaput. Now the problem with this is, if I'm not mistaken, these primary windings are actually closer to the center of the core, and then you've got the secondary on the outside, and probably this secondary right on the outside. But I'm going to open this up, but I'm not too hopeful. This transformer, what I'm looking for is a transformer that from a radio that basically used as a spare radio, but I'm trying to find one that has 7 centimeters between these holes and about 5.5 here, so that I can try and fit it exactly in the same location as this one. On the vertical side, there's a little bit of leeway. On the horizontal, I've just measured and it's 7 centimeters. So yeah, that's what I'm looking for. Most of the radios will be the same. The output will be about 230 volts. So effectively, you're talking about, on my main supply over here of about 230, 240, it's a 1-to-1 isolation transformer with a secondary winding that, another secondary that provides the high current 6.3 volts heater supply. So it shouldn't be difficult. You could probably use the transformer from just about any radio. I'm going to look for one that, that has the same number of tubes, because of course the important thing here is the current draw. You don't want it to draw a lot more current, or you don't want a transformer that supplies a radio that draws a lot less current than this one. Otherwise it'll overheat. So the radio I'm looking for is one that has the same tube lineup. The current draw is practically the same on these radios. It shouldn't be very different. There's only 2 dial bulbs, dial lamps. They can draw quite a bit of current, but if that is a problem, I can always change them to LEDs. So, okay, that's my next task, find a replacement transformer. And the main criteria is not so much the voltage, because I know they'll all be the same. It's how well will it fit into that bracket over there. I've got my work cut out for me. I've got to go into the storeroom. After quite a bit of time and digging, ruffling through old chassis that I had in the storeroom, the mess is still here, but now I have this. I have a new transformer. You'll probably notice a few similarities between the two. This is the old one. This is the new one. Now, I know this one's got a blown primary. It's not fully blown. There's obviously a short in there. Probably some of the coatings on the primary have, you know, probably melted and they get hot. And as they get hot, they start shorting out more and more of the windings. But this one works. And look at this. If I take this transformer and I put it sideways, what we have is pretty much an exact replica. These two are identical physically in terms of dimensions. I mean, look at that, 7 centimeters. We've got, what is that, 5, 6 centimeters there. We've got the same on there. So this one will fit exactly in the space that I have on the radio. It is connected sideways. So what they've done is they have put it up like that. This was bolted to the chassis, upright, and it's got these markings here as well. They're exactly the same as those guys over there. Okay, see the selectors there? Same voltages, I believe it's the same voltages. The fuse is in the same place, so you can tell this thing's from a Nordmende. And it's actually a Nordmende that I've had for ages. Somebody wanted to dump it. It was completely messed up at the top, but some of the parts were good, and I kept it, left it in a corner of the storeroom I have in the basement. And here it is. And in fact, it's in better condition than that one. So I'm going to connect this up. I'm not going to dismantle this yet, because what I will be doing is taking these screws out and I'll be fitting it exactly the way this one is. I will be wiring it like that with this part on top. I'm going to use that part of it because it fits nicely onto the chassis. That one there is too small. I'm wondering if I shouldn't just... No, I will rewire it. It's easy enough. I just have to follow the conventions of the wiring to the same points on there. I've got one clip that I've got to resolder on there, the one that broke off, this one. And I'm left with a transformer that's identical to that one. This one here, these are the two 6.3 volt heater windings. These two, they're even the same color. This is the secondary, the high voltage secondary. But I want to show you something. I want to wire this up. I'm going to connect this up and see what voltages we get. And here we have this thing connected. The primary is in there. It's 240 selected at the back. And I believe it's selected at the back. Let me check. Yes, it's on 240. I've got the secondary wired up to the multimeter. It's on AC volts. Here's the 6.3 volt winding. I'm going to switch on the dim bulb tester with restriction, just in case, and see what voltage we get on there. Ready? I've got one light bulb only, 40 watts, and let's hit it. 230 volts, 50 milliamps, and we get 236 volts. Now remember, that transformer we had before said 230 volts on the secondary, so we're getting practically the same secondary voltage, a little bit higher. In fact, this will be a little bit lower because without a load, this thing is pretty high. When the load comes in, it'll bring it down. So what I wanted to check is that it's not much higher. If it was higher, we would probably have to put a resistance series on there. But it is, well, it's within the ballpark. If this is too low, I can always just connect the back there to 220 and I'll get this up probably another 20 volts. But it should be good enough. And I'm going to check the 6.3. Now I'm going to switch it off because I don't want to mess around here and create a bad example. You know, do as I say and not as I do. But let me just play it safe. Switch that off. And we've got the secondary at 6.4, 6.5, 6.6. This thing's going to do beautifully. It's going to work because 6.6, when loaded, it'll probably come down a bit as well, quite a bit. We'll check when we've got it in the radio. The point is that we've got this transformer working beautifully, and I've got a replacement for that. Now, I want to just focus on this a bit more. Let me switch that off again. And the reason I want to focus on that is that one of you has actually come across exactly the same problem as I had with this guy. Shorted primary. Now, what do we do when we replace this? How do we replace a transformer on a radio? In one of my videos, I think it's the one where I show you how to test the transformers, I say something like, you've got to test the transformers because if one of those is off, blown, your project is dead. Well, not really. Not really. Not when you look at what it is that you're trying to achieve when you need to replace one of those. What exactly are we replacing here? This transformer looks fairly complicated. You know, it's got all these wires, it's got all these connectors, it's got a selector, it's got a fuse, it's got all sorts of stuff. But ultimately, this is actually pretty simple. It's very, very simple. A transformer, if you look at it in the simplest form, has a primary and it'll have a secondary. And in our case, it actually has another secondary. And that's really it, right? That's really all it is. It's a transformer that takes your primary voltage, whether it's, call it 120 or 240 volts AC, and it produces your secondary voltage, which in this case, as we've been shown, is about 230 volts AC. And this one here is 6.3 volts AC. So what transformer do I need for this? Well, you need about probably less than 100 milliamps over here, and probably about, well, you can work it out, but this one's about 2.4 amps over here. This secondary is usually pretty much, it's thicker wire because it's going to carry, it's low voltage, but it's going to carry more current. And you need that because your tubes draw quite a bit of current. Now, what tubes do we have here? Well, you've got the usual arrangement of tubes on here. It's you've got the FM tube, which is either 1 or 2 triodes. You've got your mixer oscillator. You've got your IF amplifier. You've got your detector, which is usually just 2 or 3 diodes and a triode. And you've got your power tube. Oh, and you've also got your magic eye. Now, the amount of current that these guys draw, if you look at the heater voltage, heater supply, you could just look at a data sheet and you'll find out that something like this will draw probably 150 milliamps. That thing, I think, draws 300 milliamps. So if you add this all up, it does go into the, about 2 amp range, or probably a little bit more, can go a bit more. But most of these heater transformers will be prepared to supply that, unless it's, one of those very small transformers that's for a preamp. But these are prepared to supply that. This thing here, what supply do you need here? Well, if you look at the power tube, you're probably looking at about, 30 milliamps. But then everything else is really, really small. The whole thing here, these guys will probably draw about 5 or call it 10 milliamps. So it's not a big current draw. In fact, 100 milliamps is probably much more than you need, which means that any transformer that you get from another tube radio with the similar, it doesn't even have to be the same, but with a similar tube lineup will be good enough for this. And believe it or not, if you're used to working with, in this case, German tube radios, the way they bias the power tube will make it draw about the same. The power tubes are almost always EL84s. In this case, we've got a EL41, but again, the same sort of power draw, the same sort of biasing arrangement. So the same sort of anode voltage is required, which means that if this secondary works for one radio, it'll probably work for another radio. So you can grab a transformer from any radio that has a similar tube setup and replace it in here. I say that with a little bit of care because just my luck, there will be 1 or 2 that won't be suitable. Sometimes you get the secondary that's center tapped. That might not work for you. But what I'm trying to say is, if you have a blown power transformer, the biggest issue is actually the physical issues with it. Does it fit in the space? Can you desolder everything and make it fit in the space that you have that the old transformer came from? And in our case, it's a resounding yes, because this is exactly the same size as the previous one. So it'll fit exactly where this one was. But that doesn't need to be the case. You don't need to fit something exactly the way that was. In fact, if you wanted to, you could leave this outside. You could leave this sort of in another part of the chassis and just wire everything up accordingly. And really all you need to wire up is the heater voltages, the secondary, right? You've got your secondary here. You've got your heater secondary. You've got your main high voltage secondary. And you've got to wire up the input voltage and a switch, which is these 2 wires over here, which happen to be, in fact, the same layout that we have over here. So that's what I'm trying to say. If you do have a problem with your transformer, don't necessarily give up. It does not mean that your project is dead. These things are very difficult to find new or, even new old stock, but they are very easy to find on old chassis. And there are a lot of old chassis out there that, as sad as it is, just have absolutely no chance of being, rejuvenated, either because the chassis itself is all rusted through or the IF transformers are messed up. And again, when I say what I've said about being able to replace a transformer like this, you can do the same for everything else. You can find replacement IF transformers. The radio that I took this transformer from has exactly an IF transformer like this one. Looks exactly the same as this one. It might not be exactly the same, but you can replace it. You can actually Frankenstein the whole thing if you want to. It's not something I like to do because I do like the radio to be as original as possible. But if the choice is throw the whole thing away or put a little bit of Frankensteining in, I'll go for the Frankenstein any day. So let me sort this out, let me put this back in, and then we'll test it and carry on where we left off. Well folks, here we go. This thing is in place. It's fit exactly the same way as the other one. I wired up the wires to those input voltage selectors. The fuse is fine. Everything is screwed on as it was before. Just one note, the transformer I had an extra tap. This is 110, 125, 150, 220 and 240. The transformer actually had a 180 as well. So that winding is wrapped up there, you know, with heat shrink. I'm not using it. I'm leaving it exactly the same as it is here. And I've wired everything up. And now for the good news. I think it's time to test it. Actually, I'm lying. I've tested it already. Watch this. I'm going to leave it on one light bulb and switch it on. The radio is on at the front here. I've got it set to FM. Not worried about that right now. I'm looking at that. Now, according to the schematic, we're supposed to have 280 volts and the current draw is about 65 milliamps. So we want about 280. Put the volume down, we don't need volume. So we're a bit low, right? But I'm going to give it another light bulb. So now I've got 100 watts in series. We're up to 269. We see no reason for concern. Put the volume off. And I'm going to bypass the dim bulb limiter. 290. And it's coming down. And if I give it a bit of volume, so we're at 288 and I've got the full supply on, no limiting, and that's supposed to be 280. Now that is perfectly fine. 8 volts on 280, believe me, it's not going to make any difference. I just want to test the heater supply. Let me switch this off here at the dim bulb and then change the meter around. So I'm going to measure the heater supply, which is over here. It's also referenced to ground. AC volts. Let's hit it again. 6 volts. 6.1. Again, that is perfectly fine. You know, it's supposed to be 6.3, but, you know, 0.2 volts on this makes absolutely no difference. In fact, it just lets the tubes run longer. Now, what I've done here really, I'll switch it off before I go yapping. I'm not afraid of the transformer. I'm afraid of something here slipping or something like that, because it does happen. It does happen. You can mess things up when you finished it simply because your meter slips or something stupid like that. Now, what we've got here is the transformer's has been put in exactly the same as before, and it's set to 240 volts input. My main supply at the moment is about 230, so it can go a bit higher, which means that that heater supply from 6.1 could probably go to 6.2, no problem whatsoever. The 288, if it goes up to 290, 295, absolutely no problem as well. You know, this is tube gear. What is it, 10, 15 volts makes very little difference to you. You could go to the extreme of putting a resistor in there. I'm not going to do that. I really don't want to do that. The reason it's high is because the voltage drop across here is now a lot lower. When this was a selenium rectifier, you'd have probably 10, 20 volts drop on there. At the moment, we've got 2 diode drops, so 1.4 volts. So we could do a resistive dropper between here and the first B+. But I really don't see any need for that. A little while ago, my supply came down to 224, 225. So, you know, this thing's going to vary slightly anyway. So this is it. The Frankenstein transformer is in. It's actually looking very good because it's very similar to the other one. And that was pure luck. Honestly, I had no idea that I'd find a transformer that's identical to the other one in terms of physical dimensions and the holes in the right place and everything else, and the same sort of wires coming out. But sometimes you get lucky, and this is one of those times for me. So this is just to show you, and this is to show one of my viewers who's ran across exactly the same problem. Sometimes it is the primary. Sometimes it is your power transformer. They do die. So don't throw the project away. You can leave it around for a while. You probably will find a transformer that'll suit. Test it out. Probably, you don't have to go into actually fitting it onto the radio. You can just connect wires and make sure that you don't get zapped, but you can test it out. And it's not as critical a component as we sometimes make it out to be. It is important, obviously, and they don't, you can't find these things in most suppliers, but if you look for old chassis, some of those are just totally messed up. You basically have rust everywhere. Those transformers, most of the time, will be good. And hey, stop building a bit of a stockpile of old gear, because you never know when you'll need it. So I'm going to stop this video here for now, and I hope this has been useful to you, and I hope that you've enjoyed it. So if you have, click like, share, subscribe, and all that jazz. And if you want to support the channel directly, you know what to do. You can do it on Patreon. Once again, thanks for watching. Bye for now, and stay safe.